All right, so we're talking about using proportional relationships today. Um, that's our topic. What's the essential question you ask? We are looking to see how can we use similar triangles to solve problems. The answer you say is we can use similar triangles to measure things indirectly using the fact that similar triangles have side lengths that are proportional. So let's dive in. First, we need to know the definition of indirect measurement, which involves using the properties of similar triangles to measure such heights or distances. So let's look at an example, shall we? Here's the scenario. You and your friends are standing out by the light pole, flagpole, if you will, and you think to yourself, man, today's a good day for a little bit of math magic, if you will. And your friends ask you, they say, hey, how tall do you think that flagpole is over there? You're like, psh, easy. Let me show you. A little math magic. You say, yourself, you say, well, I know I'm, 6 feet tall. This is you over here. And you look down and you see, well, look at that, there's a shadow down there of we'll say a 3 foot shadow right here. And you step it off and you say, all right, that's 1, 2, 3 feet for your shadow. And then you walk over to the light pole, and your friends think you're gonna go over there and climb up the flagpole and try to figure out how tall it is. But no, you're smarter than that. You decide I'm gonna walk off the shadow for the flagpole, and you say, all right, well the shadow ends up being 9 feet long when you step it off. Right, you get 1, 2, 3, 4, 9 steps. You just happen to have size 12 shoes, and what do you know? You get 9 feet. So then you try to figure out, okay, well, how tall is this flagpole? So you use a proportion here, and you say, well, I know I can set up this proportion to say if these two triangles are similar, that means I can solve for the height of the flagpole. If you remember back to similar triangles with old angle, you could say, well, I know that if the sun's over here and he's making a little sunshine, we got these angles coming through, and you're saying, well, it's got to be the same angles for all these triangles. That means if I have two of the same angles, then I have two similar triangles. So I can use these measurements and have proportional relationship. So that means that 6 over 3, so using right here, 6 and this 3 is going to be proportional to my height of this flagpole, x over 9. And you need to cross multiply and solve for this. So that gives you, let's see, cross 9 out of 3x, and you'd have 54 divided by the 3. Well, let's see, that ends up being 18, I believe. So x equals 18. So you got a height of 18. Boom. So you'd say your flagpole is 18 feet. A little bit of math magic for you. So also you could have noticed the scale factor in this case might have been an easier way to do it. If you say, well, it happens to be 3 times bigger for the 3 to the 9, you could have multiplied 6 times 3 to get 18. That works as well. Tomato, I say. Another example. So let's look at, we're at the beach, right? Look at these palm trees, and, you think to yourself, you got, it's like some kind of wooden stake. I'm not sure exactly what it is, but it's 1 meter. You see it's 1 meter on the side. You're like, man, we're going European on them here with the metric system. We got meters, and then you look and see that the shadow of this post, if you will, is 1.6 meters. And for whatever reason, your mind pops into meter mode, and you just know it. It's just there. And you got 1.6 and 1, and you think, all right, well, how tall is this palm tree? We got the same relationship here where we could use similar triangles. So I could say, what's the height of this thing? So I set it up and I say, well, I'd have set up my proportionality statement saying, well, xy over zy is going to be equal to ab over bc. So I'd plug those in, and I end up saying, let's see, it'd be 1 over 1.6 is equal to x over 7.2. And then I need to multiply that out, so I get 7.2 equals 1.6x. Divided by the 1.6, you end up getting, I don't know. I think that would be, I think it ended up being 4 straight up. So you end up getting 4 for your answer on that, I believe. And then, let's see, moving on to the next example. Spider-Man, he's over here. He's hanging out, doing his Spider-Man thing. You know him. Just hanging out around Central Park. He's flying around, and he's trying to figure out how tall is the statue that he's sitting next to. So Spider-Man, he's pretty. He's a science guy, right? He knows his math, so he figures out. Well, hey, I can do some math here to figure this out. So it'd be nice if we had Spider-Man. Oh, what do you know? There he is. He's hanging out right here, and then we got our two right triangles. So we have Spider-Man is 5'4". So he's 5'4", and then we have his shadow happens to be 3 feet. Okay, and then we got the shadow of the statue happens to be 4 feet and 3 inches. Now this is a little bit trickier when I'm trying to find the height of the statue, how high he needs to jump, because I have 5 foot in inches. So I'm going to have to do a little bit of calculation to figure this out. Let's set up a proportionality statement first. I'll say we have about 5 feet. I'll just say 5, and then I'll do 4 divided by 12. I'll tell you why in a second here. And then over 3, so that's the 5'4". 3, that's Spider-Man right here, his height over his shadow. That's going to be equal to the height of the statue over the 14 feet and 3 divided by 12. Now, why do I divide by 12, you ask? The reason for this is because we have 12 inches in 1 foot. So I'm just essentially trying to figure out what that fraction is. Now, it might be easier here if I go ahead and make these decimals. So say 5.25 here, and then I'll say this would be that would be 5.3 repeating here, and then I got 14.25 would be right here. If I just did 0.25, 3 divided by 12 would be 0.25, and 4 divided by 12 would be 1/3 or 0.3 repeating. All right, so now I'm going to multiply these two, cross multiply. 3 times x, that's easy, just 3x. And then I multiply 5.3 times 14.25. I get just about 76, right? It might be a little bit off depending on how many 3's you put in this one right here, but it ends up pretty close to 76. So then I divide by 3 on both sides, end up getting, let's see, 21, 2 goes in that, 25 and some change. I get 0.3 repeating as well. So we'd see in this case, we're going back. We'd say we have 25 feet. So x is equal to 25 feet. And then how many inches? Well, it's 0.3 repeating, so it's a fraction. It'd be 1/3 of the 12 inches. So that'd go back to be 4 inches. So 12 feet and 4 inches. And there it is. Also, I think I might have messed up on this one. It should have been 4.5, I believe, instead of 4. So 4.5 meters on number 2. Whoops. There we go.